quantitative methods. In this episode, we'll talk about the measures of location, like the mean, median, mode, upper and lower quartile. We will learn how to calculate mean, median, mode in 3 different data structures: untabulated data, tabulated group data, and tabulated ungrouped data. Now we'll go over these data structures one by one. Untabulated data is just a sequence of numbers and figures. This is just a sequence of numbers that shows the outputs of firms during 5 months. For this data, we have to calculate the monthly mean, median, mode, lower quartile and upper quartile. Before we go on to calculate the mean of the data, we have to get acquainted with the sign sigma. Sigma is a Greek letter that represents the sum of a sequence. In our case, sigma on top of it is given with n, which is the upper limit that shows where to stop, and the lower limit, k. In this case, k is equal to 1, meaning if we have to add the values, we start from k, which is equal to 1, and end at n, which means we simply have to sum all the values given in this notation. Let's look at the formula. The formula shows the sum of x divided by n, where sum of x is just the sum of all numbers. In our case, these are 40, 45, 50, 55, and 5. And n is the number of values or items. So what we do is we simply sum all these 5 numbers and divide it by 5. In our case, it's 240 divided by 5. And we get 48. Now the next measure of location is median. Median is the middle value when data items are arranged in ascending order. In order to calculate the median, we have to arrange the data in ascending order. In our case, the median is the middle number of the data set. In this particular case, we have only 5 numbers. And to find the place where median is located, we use the following formula: 5 plus 1 divided by 2. Now we want to talk about the mode. Mode is the most frequent number in the data set. In our case, we have 2 50s, and this is the most frequent number in our data set. So mode is 50 because there are 2 50s. Another measure of location is the lower quartile. First or lower quartile Q is the value 1/4 of the way through the ordered set of data. In our case, we have 40, number 1, the lowest number, and 55, the highest number. We use this formula, n plus 1 divided by 2th value. Okay, how many numbers do we have in this data set? We have 5. So n is 5 plus 1 divided by 2. This is so remember, we are just finding the order, not the actual mode, which is equal to 6 divided by 2 is, so, third. In our data set, the third number, so this is the first, second, third. So 50 is the median. Now we'll talk about how to find the lower quartile of the data. So again, just like in the median, we're not actually finding the actual number, but we're finding the value, the order of this value. In our case, again, Q1 is equal to 1/4 multiplied by n. In our case, is 5. So that's going to be 5 plus 1, which is equal to 6/4, which is 1.5 value. This is the first value. This is the second value. The 1.5 value is the value between 40 and 45. That's right here. 1.5 value. And in order to find this number, what we do is we simply find the average between 40 and 45. 40 plus 45 divided by 2, 42.5. We found the lower quartile, Q1. Now, what we need to do is we need to find the upper quartile. To find the upper quartile, what we do is we use this formula. Instead of 1, here we have 3. So upper quartile, denoted with Q3, has the formula 3 over 4 n plus 1's value. Again, here we are finding the order, not the actual value. That's why we have TH here. So what is the 4.5 value in our data set? So let's count it from the actual data set. So first, second, third, fourth, fifth, and 4.5 value in our data set is the value between 4 and 5, which is the average of these numbers. So the average of these two numbers is, so it's going to be 4.5 value. So the average of these two values, which is 50 and 55, is going to be 52.5. This is the upper quartile. This is the second section of our lecture, where we will discuss about the measurements of location for tabulated ungrouped data. Let's imagine you're given a sequence of numbers that shows the number of TV sets sold every day. For example, on the first day, you sold 3 TVs. On the second day, you sold 3 TVs. On the third day, you sold 3 TVs, 3 TVs, 4. So overall, we're going to have many days. Now, this will be a little bit uncomfortable to work with, and that's why what we do with this data is we try to tabulate it. We try to put it in a table. In order to make a table out of this data, what we do is we just count how many numbers we have for how many days. Basically, we write 3. How many 3s do we have? We have 4 3s. So that's going to be 4 3s. How many 4s do we have? We have 6 4s. How many 5s do we have? We have 1, 2, 3, 4, 5, 6, 7 5s. How many 6s? We have 6 6s and 5 7s, and we have 2 8s. We call this the X, the actual numbers, and we call this F, which stands for frequency. How many times do you see number 3? 4 times. How many times do you have number 4? 6 times. So basically, we show this number by frequency and denoted by the letter F. Now, at this stage, our task is to calculate mean, median, mode for this data set. The first thing we're going to do is we will calculate the mean. In order to calculate the mean, we will have to find the F multiplied by X. So we're going to add another column here, and we will simply multiply the X column by F column. Now that we have calculated the Fx, we will have to find the sum of all this Fx. The sum of Fx is equal to 158. Now, to find the mean for this data, what we do is we simply divide the sum of x by sum of all days. That is, sum of f's. In our case, sum of fx is equal to 158 TV sets, and the sum of f is equal to 30. So 30 is the number of days. If we add up these numbers, we're going to get 30. Dividing 158 by 30 gives you a number 5.3, which means on average, the store sold 5.3 TV sets every day. Now, the next task is to find the median for this data set for a tabulated, ungrouped data set. So the formula to find the median for this data set is the same as for untabulated data, where we have to find the middle value of this data set, which, as you remember, is n plus 1 divided by 2. So remember, we are not finding the actual value, but we are finding the order of this value. N, in our case, is equal to 30 median. $30 plus 1 divided by 2, and that's going to be 15.5 value. But how do we find this 15.5 value? In order to proceed with finding the median for tabulated data, what we do is we add another column, which is called the big F, which stands for cumulative frequency. Cumulative frequency is calculated as this. So what we do is, first we put just the first frequency, and then we start accumulate. So accumulating the previous. For example, so 6 plus 4, we write 10. 10 plus 7, we write 17. 17 plus 6, we write 23. 23 plus 5, 28. 28 plus 2 is 30. As we know from the previous example, we found the order of this median, which turned out to be 15.5 value. We have 4 3s. We have 6 4s. Together, there are 10 values. What we need is, we need 15.5 value. So what is that 15.5 value? So it's not in this group. It's not in this group. So what we have here, up to here, we have all the numbers starting from 11, 12, 13, 14, 15, 16, 17, up to 16. So we choose this line because the 15.5 value sits in here. And what is that value? And this value is 5. So your median, in this case, would be 5. So as you remember, we talked about, I showed you the sequence of numbers, untabulated version of it. So there are 4 3s. So 4 3s. Then you have 6 4s. Then you have 7 5s. 7 5s. Now let's count. Let's find out 15.5 value in this data set. It's going to be 1, 2, 3, 4. It's not in here. 5, 6, 7, 8, 9, 10. It's not in here. So 11, 12, 13, 14, 15, and 16. So our median is between the 16th, 15th, and 16th numbers, which is 15.16 value, 15.5 value, which sits between number 5 and number 5. And the average of these 5s is obviously 5. So that's why our median number is 5. While calculating median for the tabulated data, you don't have to show the sequence of numbers. the cumulative frequency column will do everything for you. So here we have up to 4 numbers, here we have up to 10 numbers, and here we have up to 17 numbers, which includes 16 and 15. To find the mode, we look at frequency. Why? Because mode is the most frequent number. So what is the most frequent number? So what you have to do is you look at the highest frequency. And looking at this raw, you find that 7 is the largest number. And again, 5 is the mode of this data set, because 5 is the most frequent, which means there are more 5s than any other number. Our mean was 5.3, and we found it using the formula sum of fx divided by sum of f. Our median value for this data set is 5. And how did we find it? Well, we added the cumulative frequency column to find out that the median number, the middle number, is 5. We found mode to be also 5 because 5 is the most frequent number in our data sets. Now, we'll talk about the tabulated group data. In this slide, you can see expenditure on food, and it's grouped. The first group ranges from 0 until 5. The next group ranges from 5 to 10, 10 to 15, 15 to 20, 20 to 30, 30 to 40, and 40 to 50. And on the second column, you can see number of respondents. So it mainly shows the amount spent on food by 50 people in a particular shop as it was surveyed. In this task, we are again asked to calculate mean, median, mode, number of TV sets sold, as well as upper and lower quartiles. Now, this is the data given. This is the expenditure on food recorded by the survey. It says from 0 to 5 and 5 to 10, 10 to 15, 15 to 20, 20 to 30, 30 to 40, 40 to 50. So these are groups. What we also should know is this data includes all the numbers up to 5. So 5 is not included in this data. And in this data, 10 is not included, but it includes 5. 10 is included, 15 is not. 15 is included, 20 is not. 20 is included, 30 is not included. And something that you have to pay attention to is the widths of these groups are different. For example, the width of this group is 5, so 0 to 5, 5 to 10. It's 5. But starting from here, the width increases. So it's not 5, but 10, 10, 10. So this is something that we have to pay attention to. When we work with this group data, what we do is we should find the midpoint of this data. We find the midpoint of this group, finding the average between 0 and 5. So the average of 0 and 5 is 2.5. So this is 2.5, 7.5. The average between 10 and 15 is 12.5, 17.5, 10, 20, and 30. That's going to be 25, 30 and 40. That's going to be 35, and 40 to 50, that's going to be 45. Now that we have found the midpoints, we can write down the frequency that is given in our task. So as you remember, the small f stands for frequency. And here we have the frequency of this data set, which means there were 2 people who responded that their expenditure on food is between 0 and 5 pounds. And there were 14 people who responded that their food expenditure is between 15 and 20, and so on. In total, there were 50 respondents. And if we add up these numbers, we're going to get 50 here. Okay, now the next step is, again, we add another column, which is fx. In this case now, we don't multiply f by this x, but we multiply f by the midpoint. Here, we multiply 2.5 by 2 and we get 5, and so on. And we add up all these numbers and get 9.995. So again, the formula for this mean is sum of fx divided by sum of f. The same formula that we used in the previous example of ungrouped data. To find the mean, what we do is sum of fx is 995, while sum of f is 50, and the answer is 19.9. So on average, respondents spent about 19.9 pounds for their food. Now, the formula to find the median for grouped data is the following. The median is the lower boundary plus the width of the median group multiplied by n divided by 2 minus cumulative frequency divided by frequency. L stands for the lower boundary of the median group, W stands for the width of the median group, while F stands for the cumulative frequency up to the median group, and F stands for the frequency of the median group. But what is that median group? Median group is, again, the group where our median is located. But how do you find that median group? We find that median group by using the previous formula that we use for finding any other medians for different structures of data. N plus 1 divided by 2. So just finding the order of the median. In this case, N is equal to 50 because there were 50 respondents, plus 1 divided by 2, you get 51. That's going to be 25.5 value. That's going to be 25.5 value. And now we used this formula given on top to find the median. Now let me write down the frequency for each of this. Now that we have the table of expenditure on food and its frequencies, we also calculated the cumulative frequency by adding up the previous frequency. For 2, we just write 2. For the next one, we add up 6. 2 plus 6 is 8. 8 plus 8 is 16. 16 plus 14 is 30. 30 plus 12. 42. 42 plus 6 is 48. And 48 plus 2 is 50. So it's basically accumulating the previous data and giving as a cumulative frequency column. The next step we do here is to use this very formula, the median, the big formula. We found the order of the median using the previous formula, which is n plus 1 divided by 2, and it turns out to be that the order of the median value is 25.5. So as you remember, to find the median number, what we do is we'll look at the cumulative frequency column. Where does the number 25.5 lie? Which is, it's not here, not here, not here, so it has to be somewhere in this group. Why? Because here we have all the numbers that start from 17, 18, 19, 20, up to 30. So it should be this group. So we call this a median group. Now, knowing that this is the median group, we use this formula where L is the lower boundary of the median group, which is 15. What about the width? The width is 5. 20 minus 15 is 5. N is 50. F is, remember that, F is not 30. F is the cumulative frequency up to the median group. So up to the median group is going to be 16 right here. And then for F, we use the frequency of the median group. Now, let's plug in these numbers into this formula and calculate for the median. Instead of L, we put 15 plus the width is 5 multiplied, open a big bracket, and divided by 2. That's going to be 50 divided by 2 is 25 minus, so cumulative frequency up to the median group is 16 divided by the frequency of the median group is 14. Now we calculate whatever is inside of the brackets. You're going to get 18.2. So the median value for this grouped tabulated data is 18.2, which is located in this median group. Now we'll talk about how to find the mode for grouped data. And for this we have a formula. So this is the formula to find the mode for grouped data, where L is basically the lower boundary of the model group, Fm is the frequency of the model group, Fm-1 is the frequency of pre-model group, meaning that it's the frequency of the group that is before the model group. And Fm plus 1 is the frequency of the post-model group, which means it is the frequency of the group that is after the model group. And at the end, we'll have to multiply the whole thing by the width of the model group and plus the L, lower boundary of the model group. Now, the question arises, how do we find the model group? Just like we did in the previous examples, we find the group that has the highest frequency. So the mode means the most frequent, which means the highest frequency. So as you can see, the highest frequency is 14 right here. So 14, and this is the model group from 15 to 20. We basically plug in the numbers from this table into the formula and find the mode for tabulated grouped data. So instead of L, we put the lower boundary of the model group, which is 15 plus, now Fm is the frequency of model group, which is 14, minus the frequency of pre-model group, which is 8. And divided by 2 multiplied by the frequency of model group, which is 14, minus frequency of pre-model group, which is 8, and minus the frequency of post-model group, which is 12. And everything multiplied by the width of the model group, which is 5. 15 to 20 shows the width of the model group, which is 5. Remember to add 15 at the end because you will have to do all the multiplication and the fraction part first. Let's do the fraction part first. 14 minus 8 is going to be 6. 28 minus 8 minus 12 multiplied by 5. You're going to get 15 plus, okay, 6, 20, okay, 8. 5. And the final answer is going to be 18.75 pounds. Okay, as you can see, the mode sits in this model group from 15 to 20, and it's exactly 18.75. To summarize our calculations for our group data, we can say that our mean 19.9, our median was 18.2, and finally our mode is, as we found, it was 18.75. So as you can see, we have different numbers for mean, median, mode, but all of them, they show the center of location. Well, why are they different? It depends on the data. Data can be distributed differently. Now let's talk about distributions. There are 3 basic types of distributions. The first one is normal distribution, where mean, median, mode are equal and the shape of the distribution looks like a bell. So that's why it's usually called a bell-shaped distribution. Well, the next type of distribution is called positively skewed distribution. If you look at the distribution, you can see that it's skewed to the right. It's also called as right skewed and looks like as if someone is pulling it to the right side. And the next one is negatively skewed distribution. In this case, mean is the lowest, while median is middle, and the mode is the largest. It's also called left skewed distribution and looks like as if someone is pulling it to the left side. In this episode, you learned about the measures of location like mean, median, mode, lower and upper quartiles. You also learned how to calculate mean, median, mode for different structural data for tabulated, untabulated, grouped and ungrouped data. Thank you for watching this video, and I really hope that this video taught you how to calculate the main measures of location like mean, median, mode with different data structures. I hope you come prepared for your seminars and will be ready to discuss this with your friends and tutor.